This is a short lecture on complement and on computing odds. The word complement is another vocabulary word for probability. What it refers to is it's a complement of an event. The complement of the event is a set of all the other events in the sample space that are not associated with it. So it's everything that isn't the event. And we're only talking about the sample space. When we say the universe, you'll see the universe in there in Venn diagrams. What they mean is the universe of discourse, not, they live off that part of the word. By saying the universe doesn't mean everything in the whole entire universe. It means the universe of discourse means the sum total of what we're talking about. In this case, the sum total of the sample space. Complement is denoted usually by a bar over the whatever the event is, E bar. Sometimes a little superscript C is put on it to mean complement. Now, if you remember from the previous lecture, probabilities cannot exceed 1. And that is used here. If you have what's the probability the event will occur plus the probability the event won't occur? Well, that's got to be 1, because either it's going to occur or it's not going to occur. You can use this idea to calculate probabilities, and if it's a real simple situation, it seems obvious, like here. If you have a probability of getting a raise at work being 12%, what's the probability of not getting the raise? Well, it's 1 minus 0.2, or 100 minus 12%, whichever way you want to look at it. It's 88%. Right. So the probability of the complement, it's a bar over there, is 1 minus the probability of the event. Again, in a simple situation, it doesn't seem like much, but it can be very useful in calculations if it's in a more complicated situation. Now we'll talk about the odds. When you talk about odds, you have to say either odds in favor of the event or odds opposed or odds against the event occurring. And the formula or the equation for computing odds, so if it's in favor of the event, then in the numerator you put the probability of the event. In the denominator you put, okay, I use colors here, the probability of the complement. If you're looking for the odds against the event occurring, then you put the probability of the complement here and the probability of the event in the denominator. Now, when you calculate these, you write odds in a certain way. You don't write them as a fraction. You end up writing them, for example, if the odds are 1 in 5 that an event will occur, you would write it like this with a colon. This could be n, or you say that's 2. Okay, 1 to 5, or 1 in 5. All right, for the odds. Now I have to say some words about algebra, because I know that the only prerequisite for this course is Math 107, and I don't know when or how long ago you took that. So let's look at rolling the die. Okay, we roll the die and we have, let's let our event be that 2 shows up. We want snake eyes. Okay, so we want the odds in favor of it. So I'm going to the probability of 2 occurring, and here's the probability of everything but 2. Right. What was the probability that 2 occurs? To calculate that, what are the number of ways that 2 can occur out of the total number of possibilities? 6 in the sample space and 1. Okay, so what's the probability that 2 does not occur? Well, it's 1 minus the probability that 2 occurs, so it's 5/6. Okay, now I'm going to put this together. 1/6 and 5/6. Now, these are complicated fractions and some people get upset about them. So let's just take a quick review on how to handle them. So first, let's look at the long way. If you have, what you have here are 2 fractions dividing each other. I've got 1/5. No, that's not what I have at all. Let me try that again. I have 1/6 over 5/6. Okay, that means 1/6 divided by 5/6. So that's 1/6. This is the long way, and I know most of you are saying, what? This is pretty boring. Over 5/6. How do you divide fractions? 1/6, you take the division, turn it into multiplication, and you flip this one. 6 over 5. The 6's cancel. You get a fraction like that. And the odds are 1 to 5 in favor of rolling a 2. So now let's look at the short way. Hopefully you'll do the short way. I just wanted to show you the long way because some people might like to see it the long way once. Okay, I've got 1/6 over 5/6. They're both over 6, which I know. Get another color here. I can just cancel those off and I get 1 and 5, so I can write that 1/5. But if there's any question about it, they both should have the same denominator, right? Because they're both with the same sample space. Okay, so what are the odds against the event? In that case, you would put the probability of not rolling a 2 and divide it by the probability of rolling a 2. So the odds are 5 to 1 for not rolling a 2. Now I'd like to say something very briefly in the in betting on horses, in parimutuel betting. They talk about odds all the time. They aren't calculating the odds this way. It's a different setup that goes on there. What they're doing is taking all the money. It's set up on taking all the money that's bet on the horses in that race, and it gets divided out over the number of people that bet on the racing horses, the winning horses, minus about 15%, which just goes to the racetrack. So the odds for that kind of betting are not the same as the odds that are shown here. If you're interested in that kind of betting, you better go study up on it, and you wouldn't be using these formulas.